Okay, good evening. Welcome back to Calculus 2. So we are to use Taylor series to evaluate the integral from 0 to 1 of sine of x squared dx. Now, I don't think this integral has a specific name, but sine of x squared, cosine of x squared, these are notoriously, you can't integrate this function. Okay, that's what class this falls into. Okay, there's no elementary functions that turn into integrals of this thing. You can't do it. Okay, no matter which techniques we have, this is not something that can be done just by, having through this. So our job is that we're going to use Taylor series, or Maclaurin series, okay, to estimate our integral between 0 and 1 for this thing. And by doing that, what we're going to do is we're going to say, hey, we're going to figure out the integral of this thing as we're going to figure out the Taylor series first, and then we'll go ahead and deal with it that way. So if I just remember the Taylor series for sine, and you'll have a table, okay? We have x over x cubed over 3 factorial plus x to the 5 over 5 factorial minus x to the 7 over 7 factorial. I'll say something like use the first four non-zero terms, okay? Now, that's just for sine x. Now it's sine of x squared. What we're going to have to do is we have to replace our x's with x squareds. So this is really x squared minus x squared raised to the third power here. Okay. So that's going to be x squared raised to the third power. That's going to be x to the 6. Okay. As we're sitting here. So that's going to be x to the 6 over 6 plus, and then we're going to put an x squared in here raised to the fifth power. So that's going to be an x to the 10th. Let's go ahead and make that x to the 10th rather than just a big 10 sitting there. Okay, x to the 10th over 120. Okay, and that's where we are with this thing. Let's see. Minus, and again, we have x squared raised to the 7th power. That's going to be x to the 14th over, and of course, 7 factorial is going to be 5040. Okay, we haven't integrated yet. We still have to do that. So we're going to do that now. Okay. And regular integration rules apply. Again, this is the one beautiful thing about series is that if you turn things into series, everything gets to be polynomials. Life is easy. Okay. So this is going to be x3 over 3 minus x to the 7 over 6 times 7 is going to be 42 plus x to the 11, 11 times 120. I calculated that out to be 1320 over sitting here. And then we have minus x to the 15th, and of course 15 times 5040 is 75600. Of course it is. Okay. And what are we doing? We're going from 0 to 1. So this isn't really too bad of a problem to deal with. Okay. If we had to go to like 2.5 or something like that, that would be worse. Okay, but we're going from 0 to 1. So this is a fairly easy arithmetic problem where we just type this in. We have 1 over 3 minus 1 over 42. Okay, let's see. In the right place here. Yeah. Plus 1 over 1320 minus 1 over 75600. Okay. So that's just what we have to do with this. We're just going to calculate that out here. That's not going to be too bad. Okay. So we just have 1 divided by 3 minus 1 divided by 42 plus 1 divided by 1320 minus 1 divided by 75,600. Okay. So let's go ahead and plug that in. I got 0.310149. Okay, so let's see here. We got 0.310. Let's go back to you over here. Let's see. Plus, minus, just double checking my signs on this thing. Okay, so we have 149,149,149,11, and then the rest, a 1. Okay. So that's how you do a problem like that. Again, it's very convenient when we have things that we simply can't integrate, no matter which techniques you have learned. Sine x squared just it defies any kind of like analytic solution. So you have to do this numerically. And a good way to do that is to say, let's go ahead and do Taylor series. Okay? There's other numeric methods. You could use Simpson's rule, you could do triangles. There's lots of other ways to do this. Okay. I'm going to say thank you very much for watching the video. I'll see you in the next one. Take care until then.